Okay, so section 2.1. Addition, subtraction, property of equality. So for the next few examples, we're just going to say determine whether the given number is a solution to the equation. First thing, 7x minus 5 is equal to 4x plus 10, and they give you a value. I'm just going to call it x equal to 5. So the first couple of examples, I want you to plug it in and see, does it work? Does it create equality? If it is not a solution, you will get a false statement, meaning two different numbers on both sides, like 5 equals 0 or 2 equals 1. Clearly, those are false statements. So plug in a value and see if it's equal on both sides. That determines if it's a solution. So here we go. 7 times 5 minus 5 is equal to 4 times 5 plus 10. So on the left side, what do we get? All right, 7 times 5 is 35. Minus 5, which is going to be 30. 4 times 5 is 20 plus 10, which will also be 30. So since this is 30 and this is 30, this is a true statement. This shows that 5 is a solution. Okay. So that's how you verify. If they tell you on homework or an exam or whatever, is 5 a solution? Just plug it in and see if it's equal on both sides. Okay. Let's do an annoying one. Example 3 in your book of fractions. 1/6t plus 2/3 is equal to 7/6. And the value they're going to give you is that t is equal to -3. Now, before we start, was there any questions on number 1? Then I'll slow down a little bit. Okay. So now we have an equation. You could technically cancel fractions and not deal with it because fractions are annoying, right? but you can only cancel them if you have an equation. But in order to cancel, you do still need to know what is the LCD. What is the LCD of all three terms here?
Would it be 12?
12 is a common denominator, but it's not the lowest. 12 would work though, but it would give us bigger numbers. But the least one, if you don't remember how to find it, remember we said take the denominators and factor them into prime numbers. And then just multiply each factor that appears the most number of times. So 3 appears once, 3 appears once, right? So 1, 3, one of them. 2 appeared once there and not over there, so just 1, 2. So 6 is the LCD. So to cancel fractions, my little sketchbook over here. To cancel fractions, again, has to be an equation. In an equation, multiply by 6. Or I should say, in general, multiply by LCD. In this case, it's 6. All right, so here we go. Every single term times 6. So at this point, you can just go ahead and multiply across, but don't actually multiply, or you can see that they're going to cancel here, right? So let me show the work like we did last time. -1 times 6 will give us a -6 t over 6, so these will cancel, plus 2 times 6 over 3. Those will reduce, right? 7 times 6 over 6, cancel. 6 divided by 3 is 2. So -t plus 2 is equal to 7. Notice how now it's much prettier. We no longer have annoying fractions, and we can solve for t. Any questions on canceling fractions and equations? Is that right?
For that middle fraction, did you mean to drop down the 2 by itself, or like multiply the 2 into the
Oh, you're right.
2?
Got the 2. Thanks. That'll be actually 4, right? All right, so I'm out of space here. I'm going to go up here. So -t plus 4 equals 7. We will subtract 4 on both sides. -t equals, these are gone, right? 3. You guys remember how to get rid of the negative? T. Negative on the t.
Don't you add it on the other side?
I mean, you technically could, but then I'd have to subtract the 3 over, right? That's not wrong, but that's more steps than we need. So what we could do is just divide or multiply both sides by -1, which we'll do that on the next step over here. Because we're almost, you notice how it's pretty much done, right? It's just that minus in the way. So cancel the negative by dividing by a negative. Now I have to do it over here. So the answer will be -3. Does that make sense?
Yes.
Yes.
Any questions on the canceling or reducing or the equation steps?
No, sir.
We'll do some more anyway, but don't be afraid to ask me, okay? Let's see here. Let's move on to something else. You guys cool on this page before I turn it? There's no rush. Okay, assume you're good. Okay. So the following part, our next few examples are just asking the basic question: is it in one variable? Are the following? I don't really think we need to write these down in one variable. So let's just switch over and look at the. Well, let's write a couple, I guess, just in case. Example 4. A. So this is a yes or no question. Number one, or the first one here, 4A. Is this in one variable? It's not a trick question. Oh, we only see one, right? It's only one. So all they want you to recognize is, can you tell there's one or more? The reason that's important is because you cannot solve an equation that has more than one variable without multiple equations. So if you have one variable, you need one equation. You have two variables here. This is y and z. This is a 2, by the way. Then you can't solve this without another equation. Well, that's the only reason they bring it up. So let me show you the problems here. So no, yes, yes, right? Any questions on 4? There's something else to it. Okay, let's do some of these. So this is solving for equations. Okay. So I'm going to try to write all the steps since this is, we need to know the steps, right? So we're solving for x. I'm sure we've all done this at some point, but we're going to assume it's been a while and we're resting. So I need to solve for x and there's an 8 in my way. There's a few ways to think about this. You can think of it, the legit way is -8, -8. So what you do is subtract 8 on both sides. So x is equal to 3. Right, now if we show an extra step, just in case, right, let's show an extra step. Technically, what you would see would be plus 8 minus 8 equal to 11 minus 8. But these are gone. X is equal to 3, right? Keep the sign of the bigger one. Now, you don't have to show an in-between step if you don't want to. I'm just showing it just in case you're not seeing what's happening. Now, an alternate way to think about it when you're dealing with addition and subtraction is if you move any term to the other side of the equals, you just switch the sign. So I'm moving the 8 over here. So now it's a minus 8. So plus to minus. After doing this many times, that's how I start to think about it, because it doesn't really matter. But technically, this is what's happening mathematically. Okay. This is just something you can do in your head if you want to. Anyway, any questions on number 5? That both make sense? Okay, so here, what would be the first step?
Wouldn't you add 3.2 on both sides?
Yeah, pretty much, right? So just add the 3.2. Or if you prefer, we're moving it over and changing it to plus. Right, it was minus, becomes plus. Or they cancel and you add them together. Same thing. 4.8 plus 3.2.
Wouldn't it be 8.0?
Looks like it, right? Okay, so far, you guys all right? Not too bad, or? Let's do a few with fractions then. And yeah, some other complicated stuff. Number 7. You guys cool if I turn the page? So don't forget, we will be on campus on Tuesday next week. Pretty sure nothing is going to change at that point. You never know these days. Okay, so here we have fractions. We can deal with it, or we can cancel them right now. So look at the denominators. That's going to be what? 4 times 3, which is 2 times 2 times 3. We have 9, which is 3 times 3. So there's my prime factors. I wrote it again just so they're right next to each other. That was for no reason. So looking at this, how many 3s are in the LCD? At most. So just count them. There's 1, 2 here, 1 there. So at most you had 2 in one spot. So you're gonna have 2 3s, right? We have 1, 2 2s, no 2s there. So 2 2. So LCD is 3 times 3 is 9. 2 times 2 is 4, 36, right? So 9 and 12 both go into 36 evenly, and it's the smallest one. So cancel fractions, we said, by multiplying by the LCD. On both sides. Okay, so 36 times everything on both sides. It's gonna be 36x plus 36 times 8/9 equal to 36 times, well, here we can just go ahead and multiply across, but I'm gonna save that step for the next step. 7, by the way. So 36 times 8, that's going to be right here, divided by 9, which will reduce it. 36 times 7 divided by 12, which will reduce. So 36 divided by 9 is a 4. 36 divided by 12 is a 3. Oops, just 21. Okay, so right here, multiply by 36 is what happened. Here is reducing / simplifying. So it'll be 36x, 4 times 8, that's going to be 32, 21. Subtract 32. Show the step first. So minus 32 minus 32. So that's the same as just moving the 32 over and subtracting, right? So what is 21 minus 32?
Wouldn't it be 11?
That looks like 11. Is it negative or positive?
Negative.
Negative.
Negative. Okay, so now the last step, right? Divide by 36. Divided by 36. So here we avoided dealing with fractions because we canceled them. Any questions on any of the steps? Okay, you guys good then? All right, let's do something a little harder. So that was the one with fractions. We canceled them and then we solved for x. This one will have parentheses and multiple terms. You guys cool on this page?
Yes, sir.
Okay, just let me know. Put our just try number 9. 4x plus 3 times 3 minus x is equal to negative 20 minus 5. So we have to distribute the 3, deal with the parentheses first. Over here, we can combine those like terms, right? So that's going to be negative 25 probably. So distribute. 3 times 3, 3 times negative x. Negative 20 minus 5. So very similar to the other examples, except we have this new parentheses thing. 4x minus 3x. So here we can put the like terms together, just so it's obvious that these will reduce or combine into x. At this point, subtract 9, and you're done. Okay, let me write the steps here. Distribute 3. Combine like terms. So that was actually this term here. By 9 on both sides. You guys cool on number 9?
Yes, sir.
Okay, that's pretty much it for 2-1, unless you want some more examples on these type of problems. You guys, does it make sense? If not, I'll move on to something else. Okay.
Can we try number 10?
Yeah, we do it. Oh, there it is. See number 10. 2/3 equals P minus 5/4 plus 1/2. Oh, 1 second. Okay. Let's see, where is it? Okay. Sorry about that. I was trying to find another pen, but I think I'm out. So what is the LCD of 3, 4, and 2? We can cancel the fractions now. So let's break it down. 4. 2 is prime. 3 is 3. So what is LCD?
Would it be 3?
For sure has 1, 3, right? How many 2s does it have?
Yeah, it wouldn't be 3 times 2, yeah.
So we got to count the most number of 2s that appear. So here we have 2 2s, 1 2, and 0 2s, right? And so we pick the one with the most number. That's going to have 2 2s. So 3 times 2 is 6, times 2 is 12. Does that make sense on how we find the LCD?
Yes, sir.
Okay. So now we multiply every single term and cancel the fractions because we chose the LCD. That's how it works. If you get the LCD, you can cancel all of them. Okay, so here we go. 12 times 2/3 equals 12 times all of this garbage. Twelve times 2/3. More space. This is not enough space. Twelve times 2/3 equals to 12p minus 12 times 5/4 plus 12 times 1/2. So we're going to get 12 times 2/3, which will reduce, right? These right here. $12p, so that'll be 12 divided by 4, that'll be 3. Minus, so that'll be 3 times 15, right? Right here. Okay, so 4 times 2 is 8. 12p minus 15 plus 6. Okay. That 15, -15 plus 6 is going to be 9. Right, combine these like terms, add the 9 over. Notice if I have the variable on the right hand side, then that's okay. We can always write it the other way. Technically, you could say this is the same. My arrow here. This is the same as 12p minus 9 equal to 8. Right? They're still equal to each other. So why not write it this way? You don't have to do this. I'm just letting you know this is the same. So now plus 9 plus 9. 12p is equal to 17, right? Is that right? 8 plus 9? Yeah. So finally, divided by 12, I ran out of space. This would be 17 over 12. So right here, we multiply by 12 and simplify. It's pretty much what we did for most of it. After that, we're just moving things around. Any questions on any of those steps?
Yeah, so that last step you did on the very last one, how you rewrote it, so that's just, you said it's the same, so it doesn't matter how you write it.
Now, we could have left it over here and solve for p, and then you would have had the p on the right side instead of the left side, which is still an answer. Like 2 equals p is the same as p equals 2. Doesn't matter.
Okay, so we could have wrote it as 17 equals 12p.
Oh,
I
yeah.
mean, 17 equals p. I mean, 17 over 12 equals p.
Yes, that would have been fine. I just chose to put it over here just because we're used to having it over here. I just did that for fun, but there's no reason to do this. Preference is the reason. Okay. Well, I was checking the schedule. Where were we? Okay, you guys cool on 2.1? That's pretty much it. We're just gonna solve for x by adding or subtracting, and you may have to deal with fractions. So we're gonna do more multiplication and division on the next section. We did a little bit here, but we're gonna do more of it on the next section. You guys cool on this page?
Yes, sir.
All right. And then we're probably gonna do some extra sections today just because we took that day off. So we're a little behind, not a lot, but it's a little bit. The multiplication property of equality. Okay. Number 1. So it starts off with 3x equals to 27. So the only choice here is to multiply or divide. So they're almost the same. So let's do it in 2 different ways here. So we can either divide both sides by 3, which is perfectly fine, giving us what? What is 27 divided by 3? Does it reduce?
It's 9.
9. So no big deal, right? Now you could also say, and multiply both sides by 1/3. That is the same thing. Most of the time, most people don't do that unless they have to. But it's perfectly equal to this. Because you see, you're gonna get this anyway, right? Does that make sense? Any questions on this? Okay, let's move on then. Example 2. W over 5 is equal to 1.1. So we can multiply both sides by 5 to cancel this fraction, right? Like we've been doing with the LCD. It's perfectly fine. So you can say, you know what? If I cancel this 5, then I will no longer have to worry about it. So these are gone. W would be equal to 5.5, right? So from here to here, we said multiply both sides by the LCD. It's technically what happened. And once the fraction was canceled, we were done. Any questions on 1 or 2?
No.
Okay, so far not too bad, right? I hope. If not, just tell me. Now here we have decimals, which sucks, but we have a calculator, so it's fine. So what you're going to do is multiply, or well, either divide or multiply. You have that choice. I'm going to choose division. Divide by the same number on the x to cancel the number. Over here, we will use our calculator to find out what this is. So this is gone, giving us x equal to something. Here's the calculator that you should be using if you have one. If not, you will Monday for sure. Just let me know. Okay, so I got 0.248. Any questions on 3?
So on number 6, when it's for the 4/7 t, would that be the same way?
Yeah, you'll have to find this on that one. You'll have to find the LCD. Let's go ahead and do that one. I think. Yeah, we might have space right here. Let's do it. 4/7 t equals -14/9. So we look at the LCD of, or the factors of 7, which is prime, and 9, which is 3 times 3. So LCD will be 3 times 3 times 7. 3 appears twice, and not at all over here, so you just write twice. The most number of times it appears in one spot. 7 appears once there and 0 times there, so 1 time. What is 9 times 7?
Isn't it 63?
Yeah, looks like it. So we're gonna multiply both sides by 63 to cancel the fraction. So multiply by LCD, cancel fractions. So 63 times 4/7 t equals 63 times -14/9. Okay, so this will reduce, right? What's 63 divided by 7?
It's gonna be 9.
It'll be 9, right? So it'll be 9 times 4t equal to 63 divided by 9.
It'll be 7.
7. Yeah. So that'll be 36t equal to -7 times -4 is 20, -28. Out of space, but
Message G want to be -14, so it wouldn't be 7 times -14.
oh yeah, I don't know why before. So 7 times 14, what is that? A 98, right? Yeah. 98. -98. So now I'm gonna do it over here. Sorry guys, I hate doing that. You're gonna take 36t equal to -98. Divide both sides by 36. Does that go in evenly? No, I don't think so. So t will give us, this reduces into 49/18 negative. Getting to these steps, I skipped a couple of steps because I ran out of space, but is it clear what happened? If not, I'll redo this on the next page. Is this okay?
Yes, sir.
Let me know if one of the steps or you felt were weird or if you missed something. Okay. So let's move on to something else. You guys cool on this page? Okay. So if you see an equals, we are solving, right? Obviously. So we have a 7 in the way. So how would you cancel the 7? A quick note here. These two are the same. -1/7 times x or -7 over x is the same thing. So just multiply. Technically, you can see it, right? Multiply by 7 on both sides will cancel the 7. But if it's negative, we're going to have to do an extra step. Or you can do it all at once and say, I'm going to multiply by -7 to cancel the negative and cancel the 7. So let's do piece by piece. Let's say you didn't see it and you just went with the LCD equals to 7. So 7 times everything. Gets rid of that guy, gives me some -x equal to then you have to divide by negative. See how we have to do it anyway? So x will be -3.234. You could have just done one step, but it's okay to do it in multiple. So here to here, multiply by 7 on both sides. Divide by -1 on both sides. Any questions on this? That's straightforward. All right. Let's see. So here's the ones that are similar to it. You have any questions on 12, 13, or 14? Do those seem doable? We can do one of them. If not, I'm going to move to one of these. What do you guys think?
I was thinking about number 18.
18, yeah, for sure, we're going to do that one. But these guys are okay? Okay, so what's up? Sorry. You guys are good on these then. Okay, so I'm gonna do 18 for sure. What do you guys think about 15 and 16?
When it's 16, you just one that you input x on both sides to add them.
Yeah, pretty much. Let's do that one, then we'll move on to 18, I guess. Okay, so x minus 3 is equal to 5x. So you have x's on both sides, so it's a little different. So there's many ways you can do this, right? You can minus 7x on both sides. You can minus the 5x over here, and then move that 3 over there. It's up to you, really. It doesn't matter. I'm going to subtract 7x on both sides. So that'll give me -3 equal to 5x minus 7x, which is -2x, right? Now divide both sides by this -2 here. This will become a positive, and this will solve for x. Okay, so no questions on 16. Go to 18. Okay. So there's a few ways you can do this. If we could multiply by 7 and cancel all the fractions, but notice how they're already the same denominator. So you could just combine the x's and combine the numbers. So that's what I'm going to do this time. I'm going to move this x term over here. And if I move it to the left-hand side, it switches to plus, right? Or you can think of it as adding 2 7s to both sides. -2 plus 2 is a -5 over 7. Now move this 36 over. And you get 92 minus 36. 92 minus 36. What's that going to be? 50 positive, right? 56. Now the question becomes, how would you cancel the -5 over 7 on that x?
I have a question. How'd you get 5?
Oh, sure. That is because I can't count. That's a 4. Thanks for telling me before we got too far. Okay. So how do I get rid of that -4/7?
When did you add it on both sides? Or multiply it?
Yeah, either way, you can divide by that fraction, right? Or you can multiply by the reciprocal, which will be the same. So multiply or divide both sides by -4/7 is one option. Doesn't look pretty, but that's legit. These are completely gone. So 56 times -7/4. So now we just deal with this. But did that step make sense from here to here? Do you see what happened?
Yes, sir. I see what you did.
And don't forget that when you divide by a fraction, you flip it, right? Take the reciprocal of it and multiply here. So that'll be 56/1 times a -7/4, which will give us 56 times -7 over 4. So these will reduce, right? How many times is 54 going to 56? I'm getting 14. You guys get 14? Multiply by -7 and we'll be done. So x is equal to 90, -98. Any of these steps don't make sense? Is this okay?
Yes, sir.
Okay. Alrighty. So that's pretty much it for 2.2. Unless you have a question on any of these other ones. If not, we're going to end it here. You guys good on 2.2? Oops, sorry. I think we have time to start 2.3, so
Can we do number 20?
yeah, we got time for that. Let's do it. Number 20. Many ways we can do this, but let's think about it. 8/5x equal to 0.5/14. Now, I'm sure you've noticed I haven't mentioned or used cross multiplication or none of that nonsense. I'm not against it. If you want to use it, fine, but I don't like talking about it because people forget when to use those types of techniques. Those tricks and shortcuts are only good if you understand the basics. You don't get the basics and you try to use shortcuts, you're going to mess it all up. So I'm not going to, so don't worry about all that stuff. Now, anyway, 5x is on the bottom, right? It needs to be on the top. technically you can flip over both sides of a fraction anytime you want. You can take the reciprocal of both sides. So this is technically equal to the original. See what I mean? You can do that anytime you want. I did it here because it's helpful. Now 14 divided by 0.5, that's going to be 28. That's a fraction, right? Okay, so multiply both sides by 8. Oops. 28 right there. These are gone. So now I have 5x equal to 8 times 28. This will be 2, 2, 4. So now divide by 5 and you are done. A little faster because we have 3 minutes left. This does not reduce. So right here, I'll write the note, take reciprocal of both sides. Multiply both sides by 8. Divide both sides by 5. And that's it. Any steps that you missed or don't understand or were strange? Is it okay?
No, sir.
Now, don't be shy to ask questions. You can always raise your hand on the little emote thing, or you can send me a private message if you don't want anyone to know. I don't care. It's up to you. But if you don't have any, I'm going to assume you are a pro. Okay, so we will do 2.3 next time on Thursday. I know, I don't know if they're going to cancel it because we're going to have that freeze coming in again. But we'll see. We'll see how it goes. Hopefully not, because we're a little behind, but it would be nice to chill on Thursday, I guess.